Earth isn't the only pale blue dot in the sky. For the first time, researchers have discovered the color of a distant exoplanet, and it's navy blue. I'm Sophie, and welcome to the Countdown. In the Fox constellation, about 62 light-years from Earth, sits planet HD 189733b, a gas giant more like Jupiter than Earth. It was first discovered back in 2005, but a study in Astrophysical Journal Letters is shining new light on its color and chemical makeup. Using the Hubble Space Telescope, researchers watched as the planet orbited its distant star. Then they compared the color of light coming from the star and its planet to the light coming from the star alone when the planet was out of view. This revealed the blue color. The researchers think the color may come from light reflecting off of silicon-filled clouds in the atmosphere. So, essentially, we're talking about a blue planet where it rains liquid glass. Now that sounds like a sight worth seeing. On July 1st, the SETI Institute's Mark Showalter discovered a new moon circling Neptune. He found it by studying old Hubble photographs. This is the 6th moon that Showalter has identified, and the 14th for Neptune. But why did it take so long to find an object so close to us? To start with, the moon, labeled S2004N1, is only 12 miles across and incredibly faint, about 100 million times dimmer than the dimmest star the eye can see. Secondly, the moon is easy to miss even from up close. Way back in 1989, the Voyager 2 spacecraft failed to detect S2004N1 when it surveyed Neptune on its way towards the edge of the solar system. And finally, Showalter had to look beyond the planet's rings to pick out the tiny moon. It orbits Neptune once every 23 hours from a distance of over 65,000 miles. Now he has to come up with a name, ideally something related to Neptune, the Roman god of the sea, or his Greek counterpart Poseidon. At the moment, he favors one of Poseidon's monstrous offspring, either the Cyclops Polyphemus or Lamia, a goddess who was turned into a child-eating monster. To study neutron stars properly, researchers need a good way to determine their essential properties, such as size and 3 other traits that determine how fast the stars spin and how they deform under the influence of gravity. I won't bore you by describing the moment of inertia, love number, and quadrupole moment, which I'm sure you already know about. But now, researchers at Montana State University have discovered that these 3 traits are intertwined. If scientists can measure just one of the 3, they can calculate the other 2. The findings, which are published in the journal Science, will help astronomers tell the difference between neutron stars and quark stars, which are made out of so-called strange matter. Our planet has plenty of meteorites that originated on Mars. These samples of the Martian crust can tell us a lot about our neighboring planet. But there's just one problem. We still can't figure out how old they are. In the past, estimates of the meteorites' ages have differed by billions of years. According to a study in Nature, there's a new solution to this problem. Scientists examined the Martian meteorite known as Northwest Africa 5298. Turns out, the space rock contains evidence of a melting event that occurred on Mars 4 billion years ago. This number is not, however, the actual age of the meteorite. The object dates back 187 million years, when the crust of the planet actually formed. Not only did the researchers reconcile the age difference, they also learned about the geological history of the red planet. Billions of years ago, it contained a hot mantle under its volcanic crust. The huge black hole at the center of the Milky Way is getting ready to consume a big meal. It's currently pulling on a large gas cloud, stretching the material way out of shape. Gas cloud G2 is 3 times as massive as Earth, and all that matter is twisting in a spiral around our galaxy's central black hole. Eventually it will be pulled in, but one question remains about G2. Is it a simple gas cloud, or is there a star hidden in its depths? As it swirls into the black hole, researchers say the mass is behaving like a gas cloud, but the fact that it has remained intact rather than crumbling apart suggests there may be a star within the cloud holding it together. We won't know for sure until next year, when the cloud will be closer than ever to the black hole. At that distance, a gas cloud alone wouldn't be able to hold its shape. If there's a star in the center, it will hold the cloud together, and if not, it will break down in the grip of the black hole's massive gravity. I'm Sophie Bushwick, and that's your countdown. For links to all of these stories and more, visit scientificamerican.com/thecountdown. Till next time, I'll be waiting for the right quadrupole moment.